Hi, ready for 4.5 and 4.6 review? Here it comes. Okay, a line has slope m equal 3 and contains the point 5, 1. What is its equation in slope-intercept form? Well, to answer this, we need to use the point-slope form, which is m times x minus x1 equals y minus y1. The x1 and y1 correspond to a specific point on the line, in this case 5, 1. So our x1 is 5, our y1 is 1, slope is slope 3. The x and the y correspond to what we can think of as a generic x and y, any solution point on the line. So for the x and y, we just write x and y. Those are coordinates of a point on the line. So that's our equation. Now to get it in slope-intercept form, we just have to multiply it out with the distributive property, add 1 to both sides. And we get 3x minus 14 equals y, or y equals 3x minus 14. Okay, here's another problem. Same type of problem, just a different slope, a slope that's a fraction, and a point -4, 1. Find the equation of this line and write it in slope-intercept form. And once again, we just plug into the point-slope form. So try this on your own, pause the video, and see if you can get the correct answer. So we just plug in those values for m, x1, and y1, and we get 1/3 times x minus a -4. I'm going to rewrite that as 1/3 times x plus 4 before I go any farther. Now distribute the 1/3. We get 1/3 x plus 4/3 equals y minus 1. And then we just have to add 1 to both sides. Now if you're going to add 1 to 4/3, you're going to have to write this as the 1 as 3/3. So you have 1/3 x plus 4/3 plus 3/3 equals y. So 1/3 x plus 7/3 equals y. And that's our answer. Okay, next problem. A line contains the points -2, 3, and 4, 7. Find its equation in slope-intercept form. Now, in the last problem, we used m times x minus x1 equals y minus y1. Because we were given m, here we're not given m, but we can figure it out. So your first step here is to find m using the slope formula, y2 minus y1 over x2 minus x1. So find m, and then plug x1, y1 into this form, and then rewrite it in that slope-intercept form. Okay, so m is 7 minus 3 over 4 minus a -2 makes 4 over positive 6, which we can simplify to 2/3. So now plug that in, and x1, y1. Now it turns out you could use either point. We're just going to use the first point, and then see if you can get that final equation in slope-intercept form. So pause your video and try that. So we plug the slope in, the x1 in, the y1 in. And before I distribute, I change that x minus a -2 into x plus 2. And then you distribute 2/3 times x plus 2/3 times 2, which we write as 2 over 1, equals y minus 3. And the 2/3 times 2 turns into 4/3. So we get 2/3 x plus 4/3 equals y minus 3. Then to solve for y, we add 3 to both sides. So plus 3 to the right, plus 3 to the left. Now to add 3 to 4/3, you're going to have to change 3 into a fraction of thirds, which means we take 3 over 1 and multiply by 3 over 3 to make it 9/3. So you have to change that 3 into thirds. So we have 2/3 x plus 4/3 plus 9/3 equals y. So 2/3 x plus 13/3 equals y. And that's our equation. And you could actually check this by plugging both points in to this equation and make sure that both points result in a true statement. And it turns out that it does. Okay, we're going to look at a problem like number 4. A line contains the point 5, 1 and has slope m equals 0. What is its equation? And in the directions I say, hint, there's no work. That's a great problem. There's no work. But you have to know what's going on here. M equals 0. If we were to plot this point 5, 1, m equals 0 means you go up 0 over however many points. It's a horizontal line. And horizontal lines have the form y equals k, whatever the y value is on the line. Well, for this line, all the y values are 1. So y equals 1 is our answer. That's it. That's all you have to do. I mean, you could use the point slope form and simplify it, but you're going to end up getting y equal 1, that y value. Because every point on the line has to have that y value of 1. It doesn't depend on x. Okay, here's a problem. Here's a problem like number 5. A line contains the point 2, negative 1, and has slope m equals undefined. Now, from the notes, from the book or the notes online, same thing, you read about this type of line. Undefined means it's a vertical line. And the vertical line passes through this point 2, negative 1. And from the book, this equation has the form x equal k, where k is the x value of every point on the line. Well, in this case, every point in the line has the value 2. So our equation is just x equals 2. And you can't even use the point slope form here because there's no slope that you can use. If you try to find the slope, you get something divided by 0, which is undefined. Okay, for number 12, I'm just going to do number 12 here and explain what's going on. Give the equation of a line that is perpendicular to the line given by y equal 1/2 x minus 1. And I state the answers will vary. Well, this has to do with parallel and perpendicular lines. Parallel lines have the same slopes. So parallel lines have the same slopes. So a line parallel to this would be y equal 1/2 x plus 3, y equal 1/2 x plus 1, anything with a slope of 1/2. But this question is asking about perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. First I got to spell perpendicular. Perpendicular lines have slopes that are negative reciprocals of each other. Try to fit that in here. Whoa, just barely. So a line perpendicular to this will have a slope of the negative reciprocal. The reciprocal of 1/2 is 2 over 1, but with a negative sign, it's negative 2 over 1. So any line with slope -2 is going to be perpendicular to that line. So it could be y equals -2x plus 1, y equals -2x minus 5, and so on. There's an infinite number of lines that have a slope of -2. And we know these lines have slope -2 because they're in slope-intercept form. Okay, that's it for now. Any other questions? Post on discussions.